Hello, my name is Bill Regli. I'm the Acting Director of the Defense Sciences Office here at DARPA. The Defense Sciences Office scours the frontiers of science and engineering to look for disruptive ideas or insights, revolutionary insights, that could open up entirely new domains for innovation and discovery, and spark our program managers to create breakthrough technologies for national security. Over the last several years, we in the Defense Sciences Office have been thinking deeply about not just the products of science and engineering, but also about the very machinery and investigative tools that enable science and engineering, the human process by which we create and discover new things. What are the fundamental ingredients of innovation itself? Viewed from the perspective of science in service to national security, the patterns of discovery fall into one of two forms. In one form, a fundamental insight about the natural world can throw open a door to engineering possibilities. In the second form of discovery, there's a specific desired application or need, and we use the scientific method to harness our understanding of the natural world and develop the transformative technologies. DSO programs have produced tools and methods as well as technologies that, in and of themselves, are changing the way we conduct science and engineering. In this process, we are seeing new patterns of exploration and discovery and new architectures for engineering innovation. Currently, we're focusing on three types of questions. First are the questions about nature, the natural, mathematical, or computational world, the questions that advance our understanding of the deep fundamentals. We're exploring questions of this type in areas such as machine learning, where we want to understand the fundamental limits of what is learnable by a machine learning system, or in photon science, where we're asking what the limits are on the sensitivity and bandwidth of a photon detector. In material science, where we're studying the state of matter and how it can be transformed using extreme pressures as a way of creating new materials. The second class of questions is about how to change the world or control the physical world. These are what we might call classical engineering questions. Can I change the supply chain of a military structure so that I can deliver medical supplies in an area using only the equipment I have at hand? Can I create a metamaterial that will alter the wavelengths of light that hit a focal plane so I can see differently? We have a program developing the new algorithms that will enable unmanned flight of small vehicles in difficult environments where they have very little information and no GPS. In manufacturing science, we've developed frameworks that will allow us to qualify for flight mechanical parts made with additive manufacturing processes, commonly known as 3D printing. We have a program in material science where we're looking at special materials that themselves can replace complex devices. For example, material that transduces heat and produces electrical energy could be used to charge a battery using waste heat from an exhaust system. The third class of questions are those about people, the human element, and society. Many of these questions are also driven by the revolutions in sensor technologies, data science, and artificial intelligence. We've been studying how to computer augment synthetic chemistry with artificial intelligence that can help a chemist navigate that complex set of reaction sequences. We're very interested in questions of human collaboration and human-computer interaction. We have projects studying the use of collaborative gaming environments to enhance idea generation and decision-making. We have other projects looking at the mathematical techniques that will help us model and design human-machine teams so that they can more optimally solve problems in unison. In social science, we're studying questions around group identity formation. What gets a group of people to identify around a common theme or topic? That's very relevant as non-state actors become increasingly important players in national security challenges. In the course of doing this social science research, we also want to develop the new methods that ensure the research is reproducible and the results apply in a wide variety of settings. I've described three perspectives the Defense Sciences Office uses to think about the scientific discovery process and the nature of the problems we're solving: the natural world and its fundamental limits, complexity and control, the human element, and design. Viewed from these perspectives, the Defense Sciences Office is trying to create scientific revolutions in service to national security. We invite the broader community of scientists and engineers in universities, companies, small organizations and large to think about how they can align their expertise and passions with these ambitions to take on the challenges of the day. We want the broadest possible community to become our partners in creating technological surprises and scientific revolutions. We hope this perspective into how DARPA thinks and what the Defense Sciences Office is thinking about gives you some new ideas and inspires you to consider working with us. We look forward to hearing from you.